This is a lesson on similarity, which goes along with section 10.2 in digits. And two figures are similar if there's a sequence of translations, reflections, rotations, and dilations that map one figure onto the other. So what we're going to do is we're going to prove that things are similar by explaining how to move one onto the other using translations, reflections, rotations, and dilations. So it's typically best if we take the one figure and dilate it so it's the same size as the other one. And then once we have the same size, then we can translate, reflect, and or rotate so that it is on top of the other. So let's take a look at this example. We are going to prove that ABC is similar to NOP. So what I'm going to do is I'm going to call NOP the original and ABC the image. So to find the scale factor, I find the length of one of the sides of the image and divide it by the length of the sides of the pre-image. Again, I'm going to call this the this the pre-image and this is the image. Now it's hard to determine the length of this, so instead I'm going to use the one that goes along the grids because I can just count the squares for that. So I'm going to say that BC is my image. BC is my image, and the corresponding side to that is OP. So I'm going to do BC divided by OP. So the length of BC is 1, 2, 3, 4 units, and the length of OP is 2 units, which means that the scale factor is 4 divided by 2, and that's 2. So what I'm going to do now is I'm going to dilate NOP so that it is 2 times bigger, and I'm going to dilate it about the origin. So 0, 0 is O, and that will stay at 0, 0. P, which was 2, 0, is going to be multiplied by 2, so P prime is going to be 4, 0. N is the point -1, 2. If I multiply those by 2, I get -2, 4. So -2, 4 is N prime. So I'm going to connect the dots. It's best if you use a straight edge. And now what I need to do is figure out how I can transform or translate the prime, N prime, O prime, P prime, onto ABC. So I can see that it is a translation. So the first transformation I did was a dilation with a scale factor of 2. And center 0, 0. And we're really only focusing on center being 0, 0. Now I'm going to move O prime, which is right here. I'm going to move it 1, 2 spaces left. So I'm translating. So it's a translation. And the rule is XY goes to. I moved it left 2, so that's X minus 2. And I'm going to move it down 1, 2, 3, 4 spaces, so that's Y minus 4. So since I was able to use a dilation and a translation, that is enough to prove that triangle NOP is similar to triangle ABC. So the way we write that is triangle NOP is similar to, which is just the squiggle part. It does not have the equal sign underneath it. If it did, it would be congruent. So squiggle, or a tilde, is similar to in math. So triangle NOP is similar to triangle ABC. And I have proven that by using a dilation and translation to map NOP onto ABC. It is absolutely fine if you chose to do the other way, so a dilation, which would be a reduction of ABC, and then move that onto NOP. Let's move on to the next one. We are going to prove that ABCD is similar to EFGH. Now, we had a station that talked about how important it is to name your figures. So, since A is listed first here, that means it corresponds to E. So I'm going to put A in purple and E in purple. B corresponds to F, so I'm going to put B in green and F in green. And so on. C corresponds to G, so C and G I'm going to put as red. And then D and H correspond, so D and H I will have as yellow. So now what I'm going to do is I'm going to find the scale factor. So I need to match up sides. Here I have AD matching with EH. So I have AD here matches with EH here. AD is 3 units long. EH is 1 unit long. So AD, that's a D there, over EH ends up to be 3 over 1, which equals 3. So the scale factor is 3 for this one. So what I'm going to do is I'm going to enlarge EFGH by a scale factor of 3. And the center is 0, 0. So that means that E was originally 0, 1. Now it's going to be 0, 3. So E prime. And then H was negative 1, 1. So now it's going to be negative 3, 3. So that's H prime. F was 0, negative 1, so now it's 0, negative 3. And G was negative 1, negative 1, so now it's negative 3, negative 3. So here is my enlargement. And now I have to figure out how to put this onto A, B, C, D. Now, the reason it was so important to list the corresponding parts is that since it's a rectangle, it kind of looks like I could just slide it. But if I slid it, E would go on top of, E prime would go on top of D. But that's not supposed to happen. Remember that D and H need to match up. So I need H prime, which is right here, to go on top of D. And the only way that will happen is if I reflect it over a line. So the line that I need to reflect it over is right in between. So I'm going to count how many spaces there are from H prime to D. There is 1, 2, 3, 4, 5, 6, 7, 8 spaces, which means halfway between them would be 4 spaces. 1, 2, 3, 4. So that means my line of reflection is 4 spaces away from H prime. So I'm going to mark that here. My line of reflection is right there. And what line is that? That's what I need to figure out. So I'm going to reflect. So it's a reflection over the line. Now remember, when it's a vertical line, the x-axis is right here, and that value is x equals 1. And here the x value is 1, and here the x value is 1. So the line, when it's vertical, is x equals whatever number it crosses the x-axis at. So x equals 1. That is my proof that ABCD is similar to EFGH. I also want to remind you that if there is a reflection involved, the orientation will switch. So if you look at ABCD, I am moving counterclockwise. If I look at EFGH, the original one, EFGH, that's moving clockwise. So that tells me right there that there had to be a reflection involved. All right, let's move on to the next page.
For this problem, we're supposed to prove that JKLM is similar to PQRS. And again, to prove that, we are going to show that it is a series of transformations to get one to map onto the other. Now, if you think about it, remember we can make either JKLM bigger or we can make PQRS smaller. If I try to make JKLM bigger, you can imagine that I'm going to be off my grid. So instead of making JKLM bigger, I'm going to choose to make PQRS smaller. So that means that PQRS is the pre-image and JKLM is the image. The next thing I need to consider is there going to be a reflection in this problem? So if I look at the orientation of JKLM, that is counterclockwise, and PQRS is clockwise. So that means there has to be a reflection at some point. Alright, the first thing I'm going to do is find the scale factor. So I'm going to take the side length of the image divided by the side length of the pre-image. So let's figure out, if I talk about the side JK, that's here, that matches up with PQ, which is here. So JK is 2 units long, and PQ is 6 units long. So it's JK divided by PQ. So that's 2 over 6, which is equivalent to 1/3. So the scale factor is 1/3. So the first thing I'm going to do is dilate PQRS by a scale factor of 1/3. And let's see what that results in. So I need to take this point Q, which has the coordinates -9, 0, and multiply by 1/3. So -9 times 1/3 is -3, and 0 times 1/3 is 0. So that means that Q prime is at the point -3, 0. So -3, 0 is Q prime. Let's do R. So R had the coordinates -3, 0. So if I multiply those by 1/3, -3 times 1/3 equals -1, and 0 times 1/3 is 0. So R prime has the coordinates -1, 0. All right, let's go to S. So S has the coordinates -3, -6. So I'm going to multiply each of those by 1/3. That's -1. And that's -2. So the coordinates of S prime are -1, -2. Oh, sorry about that. -1, -2. And then finally I'm going to do P prime. So P has the coordinates -9, -6. So take 1/3 of both of those, and P prime is going to be -3, -2. Okay, so we have this new figure here, and I need to get P to map on to J. So P, which is right here, has to map onto J. So that means I have to flip it. I cannot just slide it up. And again, that goes back to the clockwise, counterclockwise thing that I did earlier. So now I have to decide where my line of symmetry is, or my line of reflection is. So if I take a look, excuse me, I need to also map Q onto K. So I'm talking about right here. I have K here, and I have Q here. So K has to map onto Q, and those are only 2 apart, so the line of symmetry is pretty easy for me to see. So the line of symmetry is going to be right in between there. So there's my line of symmetry. So the first thing I did is I dilated PQRS by a scale factor of 1/3. And my dogs are playing here, sorry about that. And the second thing I'm going to do is reflect over the line. Reflect over the line. And let's figure out what that line is. So if you take a look at the axes, here's my y-axis right here. Here's my x-axis. So the red line that I drew is on the y-axis at 1, and it's a horizontal line, so that means that all the y values are 1. So that means that my reflection line is y equals 1. So I did a lot of work here, but my answer is that I dilate PQRS by a scale factor of 1/3, and I should put with center 0, 0. So I'm adding the center 0, 0. And then my second part of my answer is that I reflected it over the line y equals 1. Okay, we have one more to do here. We are proving that MNO is similar to PQO. And we can choose to make one bigger, or we can choose to make one smaller. It really doesn't matter which one you choose. If I do make it bigger, I'm going to be off a little bit from this grid. So I will choose to make it smaller. So I'm going to start at MNO and put it onto PQO. So find the length of MN, and that matches with PQ. So we want to take the pre-image and the pre-image goes on the denominator, in the denominator, so we're doing MN divided by PQ. So MN is 2 and PQ is 3. So our scale factor is 2/3. So I take each point of PQO and multiply it by 2/3. So I'm going to do my work over here. My point P has the coordinates 3, -6. So I have to take 2/3 of 3, and that's 2. And I have to take 2/3 of -6, and that's -4. So my P prime is going to be 2, -4. Alright, I'm going to take my Q, which has the coordinates, sorry about that, 0, -6. Multiply each of those by 2/3, so I get 0, -4. And that's my Q prime. And then 0, 0 is my O, and when I have the center, a point on the center, it stays where it is. 0 times 2/3 is 0. So there's my new one. Now I have to decide what kind of transformation I need to do to get this image onto MNO. So the first thing I did was a dilation with a scale factor of 2/3. The center was 0, 0. And then I have to decide what another transformation is. So it's not a slide because of the way they are shaped. It could be a flip or it could be a turn. So to decide if it's a flip or a turn, I'm going to look at orientation. So the orientation of MNO is clockwise, and the orientation of PQO is also clockwise, which means there is not a reflection. So that means it has to be a turn. So if I look at how I turn it, I'm going to match M and P together. So if I connect M to the origin to P, what kind of angle is that? So that is a 180-degree rotation. So the second is a rotation of 180 degrees about the origin. Now I should put clockwise or counterclockwise when I talk about rotations. Since it's 180 degrees, it doesn't matter which way I say. So I'll just put counterclockwise. All right, so this should give you enough information to practice on your own.